Okay, so a demonstration on how I do my cars from just stuff like the steering rack to suspension. So you want to start out with a base plate. You just any kind of prop that's going to act as your base and you're going to constrain everything to. Then for your steering rack, you'll kind of just need a prop that has some width to it because you're going to want to put some leverage. That's how your hydraulic's going to work. So, prop like this will work fine. We're going to... You can kind of get it in place however you like. I just prefer to use precision alignment to move it. And then I attach it to our base plate with axis center. And then our main component, not thrusters, but hydraulics. So use a hydraulic to move it each direction. So I set my distance about 25. It'll give you a pretty good steering angle. You can kind of constrain it other ways, but this is a good baseline. You want to make sure it's set to have none of these turned on. Both of these are unchecked. Because it's fixed, it won't move, and it's kind of annoying to steer when it's a toggle. So you leave both of those off. There isn't any particular way of going about it. You know, just kind of eyeball it. So your left one goes here because it's going to push the steering rack this way and turn your wheels left. And then you do the same with your right side. Again, kind of just roughly put it in, eyeball it. It should work. Kind of test it real quick. Yeah, it works. Good enough for now. But we can assist it with thrusters. I like to assist it with thrusters. Make sure to mind the direction, since this is forward with right arrow. You're going to put it here and here. And there isn't really a determined set value for force. It's just more force means more steering power. If your value is too low, you won't have any steering power. But you can kind of go too high, but just like, I keep it around 1,000. It works for most weights and sizes. Speaking of, we're going to set the weight of all the components we have. We're going to want a heavy base plate, about 500 to 1,000, depending on how heavy everything else is. You want your base plate to be the heaviest component, because it's what's going to hold all your constraints together and keep your vehicle in one piece. And then for your steering rack, I do about 200. With the components we're going to attach to it, it keeps it plenty strong. But I thought I turned them off. Anyways, you're going to see we kind of have a problem here. We're allowed to kind of just spin freely like that. That's kind of a problem. You don't want to do that whilst you're trying to steer. So we will rectify that with an advanced ball socket. So for a lot of the constraints we're going to do here, we're going to use precision alignment. I know, ooh, intimidating menu, ooh. No, I'll show you how it works. It's pretty simple. But what we're not going to do is put this at the center of mass of our steering rack. So you have our point 1, click on our prop that's set to a center of mass. Your modes here, mass center. Select your point 2, put it on the center of mass, and then you can right click your base plate to select it, then click on attach to attach point 2 to your base plate. Because for constraints here, the point is how you select the entity to constrain what to what. So that's how you attach stuff to entities. So we can select our props. Anyways, we have our axes here. What we want to do here is restrict the angle of our steering rack. And the thing to note is X is north-south, Y is east-west, Z is up-down. And these restricted angles are world-based. So, select our points. But we want to have these both restricted, X and Y restricted to negative 0.1 to 0.1 for both X and Y. And then for Z, it's going to be dependent on how many degrees of rotation you want. I had it at 35 previously, but for this one, I'm going to set it to negative 45 to 45. This will give us 45 degrees rotation on either side. And then we want to check free movement and no collide. We want to transfer rotation, and that's what the advanced ball socket does. It doesn't transfer position, it transfers rotation. So with that ball socket in place, we should no longer have hyperextension like that. You see, it physically cannot go too far. Even with my fizz gun, it's physically not allowed. This protects our steering rack. Now, with that in place, now we can work on our wheels and suspension. For suspension, I like to do what I call axial suspension, which is an axis prop based, fully independent suspension. Basically, just each wheel can move independently of each other. It's a very simple, robust, low on constraints, simple suspension. And it gets its name from the fact that each wheel relies on an axis prop. It can be really anything. It can even be like a full arm. But for this demonstration, I think I'm just going to use this plate. You just need some sort of prop to put on an axis. So I will put it on our side here with precision alignment. And we will need our wheel. Again, just about anything will work. Put whatever you want. It's your vehicle, not mine. You can kind of roughly position it. You can kind of precisely align it with precision or precision alignment or something like that. But it doesn't really matter here. It matters is that you just have your wheel. Once you have a wheel in place, you can mirror this. So a neat little feature of precision alignment is mirroring. We will use a plane. So we will use this to create our plane, and then the hit normal to determine direction. To get it to face where you want it to go, click on a face in the opposite direction. So clicking this will make it face that way, vice versa like this, it'll point that way. Anyways, we want to mirror it to this side. We want to select what we're mirroring, go to rotation functions, mirror across plane, select play 1, and then hold shift and then click rotate entity. Because if you don't do that, it'll move it without duplicating it. But if you hold shift, it will duplicate the entity. And then we can repeat the action on our wheel by holding shift and right clicking. Shift plus right click repeats your action, whatever last action precision alignment did. Now, to get this on the backside, we click on this plane to get to this to face back here. Then we select what we want to mirror. Shift plus click. Then we repeat, 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 repeat. And you should have this all mirrored. Now, to connect our axis prop, we use Axis Center to create an axis between it and the build plate, this base plate. And then we connect our wheel to the axis prop with a center ball socket. You can ignore all these, just check simple ball socket. We don't want to mess with any of those settings. So between our wheel and our axis prop, Now for the suspension bit, I like to use an elastic. So we will create that with precision alignment. We will use mass center to create that at the wheel center of mass. So for point 1 and point 2, put them in the middle of the wheel. Then you select your base plate, attach, like you did before with your steering rack. And then in our constraints menu, we have an elastic. You can either take a screenshot of the settings. I'll also have these written down. So these are the settings I use. You can play with them, turn stuff down or up, but weight's also a determining factor. So if you find you want to make your suspension more stiff or loose or bouncy, you can mess with weight. But this is the base settings I use. So you have your point 1 and point 2 selected, create constraint. And then you do the same for each wheel. You select, you put both points on, attach, create constraint, create point, attach, create constraint. Same for this wheel. Now that we have our suspension, we now need to make sure our wheels are restricted in where they can roll. Because right now they'll kind of just do this. Kind of allowed to spin how they want. We don't want to do that. So to control that, we're going to use advanced ball sockets. For the back, whatever drive axles you have that you don't want to steer, you constrain it to the base plate. So you have your 2 points at the center. You attach it with ball socket advance. Our vehicle is facing here is east-west. So for east-west, you want to free the y-axis. So -180 to 180. If you're facing north-south, you do this for x, not y. But in this case, we do y. So we do that for this wheel. And then we do the same for our other back wheel. For our front wheel, we instead constrain it to the steering rack because we want the wheel to actually rotate. So we transfer the steering rack's rotation with an advanced ball socket on each wheel. So you do the same steps, but instead you select the steering rack and they're attached to the steering rack. So now we should have this. You know that whole weight thing I'm talked about? You can fix how this behaves with weight. So like I said, about a weight of 100 for each of these. Want a little less spaz on here, you can set a weight of 1,000 on the base plate. A little bit of a bounce. Yep, look at that. Now we're just gonna... We can use thrusters to propel this forward. You can do all sorts of other fancy stuff, all sorts of drivetrain stuff. But, you know, for now, you can just slap some thrusters on the back. You know, weld a seat on there, slap a seat, build a body, whatever. But as far as this goes, this should be a working vehicle base. Yeah, it's kind of jank, but for something quickly thrown together, it works. You can figure out settings, weights, other parameters. Figure out what works for you. But, you know, this is very loose. This will fit on a lot of stuff, as you've seen on my dupes. But this is how you build suspension and a steering rack with precision alignment and other simple building tools.